Okay. Hi, thanks for coming to my talk today. I'm Dario. I'm working for a company called Mesosphere, which is based here in San Francisco, but I'm working from Hamburg in Germany, where our second office is. Today I'd like to talk to you a bit about Mesos and how you can write cool software on Mesos using Scala and Akka. First I'm going to give you a short introduction to Mesos, then I will be talking about the project I'm working on at Mesosphere, which is called Marathon, and how we use Akka in Marathon. And then I'd like to show you a small experiment I did over the weekend, where I used Scala to write an autoscaling software. Okay, so first question, who here knows what Mesos is? Oh, that's around a quarter, maybe a third. Cool. And who is using Mesos in production? Okay, that's cool. So what is Mesos? Mesos is, first of all, an Apache open source project. It is kind of a distributed systems kernel. It is a multi-resource scheduler, so it takes care of scheduling CPU, memory, ports, and disks. But you can also add any other resource you like. It scales up to 10,000 of nodes. We have been seeing clusters around 30, maybe 40,000 nodes. It is fault tolerant. That means that there's no single point of failure in a Mesos cluster. And it has first-class Docker support, which I think nowadays is also important to mention. So what does a distributed systems kernel mean? First of all, of course, it runs on every node in your cluster. And it aggregates all the resources in your cluster. So you don't have to deploy your tasks on a single node anymore, but instead you just tell Mesos, hey, I'd like to deploy this task somewhere, and Mesos takes care of the rest. So you can say it's, in a sense, kind of like a thread pool, but instead of scheduling threads, it schedules tasks and takes care of the resources like memory and ports and so on as well. It provides applications with an API to do all that, to manage the resources and schedule tasks. And it offers resources to applications so that they can decide to deploy a task somewhere. A typical Mesos setup looks like this. So we have a couple of masters, where one master is the active master. And then we have a couple of Mesos slaves or compute nodes where your tasks are then actually running on. And we have a zookeeper cluster to do the master failover and parts of configuration sharing as well. And then we have the so-called frameworks. For example, there's a Hadoop scheduler, we have an MPI scheduler. Marathon is such a framework, Spark, and many other softwares like, I don't know. And yeah, so why should I bother? I mean, we have many tools to manage and large clusters, to distribute our tasks, to do task deployments. But, well, if you want to run many tasks, like really a huge amount of tasks on such a cluster, it's still pretty hard. Scaling up and down the number of tasks and machines can be very challenging. Handling failures in the cluster, like what happens if my application goes down or if a node dies. Usually someone's being called in the middle of the night, has to get up and try to fix it. And that's not really what we want. And of course, we want better resource utilization. So we have huge servers nowadays with up to hundreds of cores and huge amounts of memory. But if we just run single tasks on them, it doesn't really make much sense, right? So static partitioning as we have it nowadays looks like this. We may have a cluster that's running Hadoop, we may have a cluster that's running our database, and we may have a couple of servers running our applications. Of course, when we have all that statically partitioned, it means that whenever, for example, our Hadoop cluster is not doing any work, those resources are wasted. So what we want is, well, at least for our tasks, we could say, let's virtualize that. So we have a higher number of virtual nodes that run single tasks. So we have a better resource utilization, and that's already a win. But it adds operational overhead. Because instead of 6 servers, we now have 24 servers. And they have to be managed. So what we want to see is multi-tenancy and automatic task distribution. So we want to run Hadoop and our Play applications and our databases on the same cluster. And whenever a node fails, we want the tasks to be distributed automatically. So say hi to Marathon. Marathon is a distributed init system. So as I said, Mesos is the kernel, and Marathon in that sense is your systemd or whatever. It's also full tolerant, of course. It manages deployments, so whenever you want to deploy a new version of your application or a completely new application, just tell Marathon, hey, here's this application. You can write a definition of your application, tell Marathon how many instances you want to start, and it does the rest for you. It is able to check the health of your application. So when for whatever reason your application becomes unresponsive, it can take care of that, kill that task, and restart it somewhere else. It manages task and machine failures. So whenever a task or a machine dies, Marathon will distribute the tasks on the remaining machines. And of course, it runs Docker containers. So deploying an app with Marathon is as easy as that. Just send it a JSON definition of your application. You have, of course, to define an ID so that we can identify the application later. You can set a command. Can be any arbitrary shell command. As long as the resources are on the server, you can also send the resources together with your request so that, that Mesos can fetch the resource from, for example, an HTTP server or an HDFS share or whatever. You can define the number of CPUs your application needs to run and the amount of memory, of course. You can tell Marathon how many instances you would like to run. And you can also define ports. Ports have been a bit confusing in the past for our users because when you write down, I want port 80, that doesn't mean that your application really gets port 80. It just means that there's a service port 80 under which, for example, your service discovery mechanisms can make that task available. And Marathon will then, from the resources that Mesos offers, choose a random port and pass that in as the port environment variable. So depending on how many ports you will have environment variables port 0 to n. When you start an application on Marathon, what actually happens is that Marathon calculates a deployment plan. So it sees, in this example, we only start a new application that has not been existing before. So it calculates a deployment plan that contains a single action that is start my application. And then in the UI you can see that there's a new application and that's currently in the deploying status. And let me show you how, oh, that's not very, well, okay, let's try. So when I send an app definition to Marathon, we respond with a 200 OK, and then in the UI, oh, that's really not very, good to see. But yeah, so you can see that, maybe you can see that the number of tasks is growing. And on the middle you see this bar. That means increasing the number of tasks that are running, and when it turns green, it means that those tasks are healthy. So for every task that is healthy, the bar will turn a bit more green. And now it's running. And I just started 1,000 tasks on a 50-node cluster. Well, that of course was a recording. In reality, it took 3 minutes because it was only 50 nodes. But if you had, for example, 500 nodes, it would probably take just a couple of seconds. So what does Marathon do when I deploy a task? There's an actor called the scheduler actor that is responsible of managing all the scheduling actions that happen in Marathon. So whenever I send a deployment to Marathon, or Marathon decides that it has to redistribute some tasks, that message will go to that scheduler actor, and it will make sure that for each application only one action is running at a time. It will then notify the deployment manager, who manages all the deployments, and that will start another actor, that is the deployment actor. So for each deployment we have running on Marathon, there will be one deployment actor. That actor then, for the action we want to execute, starts another actor, depending on what action we want to execute. It may be an app start actor, or an app restart actor, or an app stop actor, and so on. And that actor then connects to the event stream and listens for the events that the deployment creates. So Mesos will send us, for all the tasks that we start, status updates. For example, I sent Mesos a message, please start this task on this resource. Then Mesos will answer, okay, I'm trying to start that task. And when it succeeds, it will send us a task running message. And for every task running message we receive, we will count up, and when we reach the number of tasks we wanted to start, then our deployment is a success. Of course, if we have health checks defined, we will also make sure that those health checks turn green before we mark the deployment as a success. We can also deploy groups with Marathon. So that is actually why there are so many different actors in the last picture. Because of course, for starting just a single application, we wouldn't need that many actors. So when we start a group of applications, the deployment plan looks a bit different. So now we have, in this step, several actions that say start application, and they will be executed in parallel. So we have now 3 app start actors that are running in parallel and deploying those 3 applications. And we can also model dependencies between groups and applications. So it may be that we have a front-end application, a back-end application, and a database. And of course, the back-end application cannot work without the database, and the front-end application cannot work without the back-end application. So we want to make sure that we deploy the database first, then the back-end application, and then the front-end application. And that can be modeled in this way. So we just say, my app has a dependency to my other app, and my other app has a dependency to yet another app. And Marathon will then create such a deployment plan that says, I have 3 steps now. And steps cannot run in parallel. There will only be one step be executed at a time. So this looks like this now. We again have only one app start actor per step, but that app start actor then for each, well, if it's done, notifies the deployment actor, and the deployment actor checks if there's another step that it has to execute, and so on. So, and then if we're done, the whole deployment is done. In reality, it looks like this. So if we have more than one application that depends on other applications, then it's a bit hard to tell in what order we want to deploy them. So what we do in Marathon currently is we put them in layers. We say every app that does not have any dependencies is in layer 1. Every app that has only dependencies to apps in layer 1 is in layer 2, and so on. So does anyone see a problem with that approach? Yes?
If the Docker container is running, you might not necessarily be listening on support, you just know that the container itself is running.
No, we actually know that it's running. So okay, the problem here is that when, for example, sorry? What?
If anything fails in layer 1, then you can't start layer 2.
Yes, that's one of the problems, of course. But another problem is if, yes. Yes. So as you can see, E is not depending on A. So if A takes a very, very long time to deploy, even though B and C are already ready, then E will not be deployed until until A is ready. And that's of course not very nice. So how can we do better? A better way of deploying dependent tasks would be to say we don't layer the application, but instead of that we start for every application an actor, and that actor will then wait to be notified by the application or the deployment actors that it depends on. So instead of having this push approach, like pushing every layer, we just wait to be notified and then start the dependencies. So in this case, when A takes a long time to deploy, but B and C are already done, E will have been notified by B and C that they are ready and can start deploying right away. And then of course D will have to wait for A, but we don't really care about that. So it's currently not implemented like that in Marathon, but that of course would be a very welcome future optimization. So how can we write custom frameworks on Marathon? On Mesos, sorry. We have bindings for many languages for Mesos. We have C++ bindings, of course, because Mesos itself is written in C++. We have Java bindings. We have Scala bindings, Clojure, Haskell, Go, Python, and probably a couple more. It has a very simple API. So in case of the Java API, we just have to implement a class or implement an interface called scheduler, and that gives us these methods. When a framework registers with Mesos, it will call the registered method. So they're all callbacks. So, and of course, if we once registered with Mesos and we lose the connection for some reason, we want to reconnect to the and register as the same framework. So there's also a re-registered method that will be called when we successfully re-registered. Mesos will send us resource offers from time to time that we can use to start our tasks on. So that method is then being called with a sequence of resource offers that we can then check if there's something that matches our needs. We have an offer rescinded method that will be called if we hold on for too long to a resource offer. Mesos may ask us to give that resource back. Because if we're not using it, of course, we shouldn't hold on to it too long. Then there are status updates. So as I said, there are different status updates. A task can change its state to running, it can fail. If it's not able to start the task at all, it may send us an error. Or when a slave goes away and didn't unregister with Mesos, it will eventually send us a task lost message because it doesn't know in what state this task is. So it may be that it will not come back again. We also have framework messages that can be used to communicate between a scheduler and an executor. So an executor is the part that runs on the actual slave. Of course, Mesos can be disconnected from the framework. Slaves can get lost, or executors as well. And there may be errors that we don't know what they are. So we have to be notified about that as well. There's a work in progress library that I have been working on for some time now, called Akka and Mesos. And it's a bit of a different approach because the current version of the Java API just uses J and I to communicate with the libmesos that's underlying that. So instead of using a callback approach like in the libmesos or mesos.jar, we have a stream of messages that we will receive from Mesos. And we have wrappers around the messages that Mesos gives us. So the communication in Mesos works with protobuf messages. And of course, everyone who has been using protobuf in Java knows it's not very nice. So in Scala, we can do a lot better. And of course, there's no J and I in those bindings. Okay, coming to my experiment with autoscaling applications. I think many people want to have applications that react to the load on the system. So if we have a web server, for example, and we receive a spike of requests, we may want to decide that it's time to start up another instance of that application so that we can handle that spike. It's of course, I mean, for some time we may have to drop some requests, but it's a lot better than someone being notified about that spike and has to manually change the number of instances, maybe even has to manually deploy a new machine to start up just to handle a spike that maybe lasts half an hour or so. So what I did, and I hope that's going to be visible a bit better than now, is based on this Akka and Mesos implementation, I wrote an application that uses an Akka cluster and collects cluster metrics. So it keeps track of the resource usage in that cluster, like CPU usage and heap usage. And whenever we pass a certain threshold, we will just start a new task in the Mesos cluster. And let's see if that, yeah, so I start up 2 seed nodes, and of course I could start them on Marathon as well to make sure that the seed nodes are always available. And when the cluster is ready to go, it takes some time to just figure out who's the actual leader and so on. Again, when it's ready to go, it will start collecting cluster metrics. And I simulated some load whenever there's the threshold is not being overpassed. So eventually it will decide that it needs to scale up. And then we'll go and tell Mesos, hey, please start a new task. And you can see here in the Mesos UI that it started a new task, and that's in state running. And it will then, of course, keep collecting the metrics, and whenever it undershots a certain threshold, so the spike is over, we of course want to free that resource again. So now we are waiting for the resource usage to go down again. And wait a bit. There. It decided that it doesn't need the resource anymore and frees it. So no one has been notified that there was a need for more resources. And it just decided itself, I need more resources, took them from the Mesos cluster, and after it didn't need them anymore, just released them. So how does that work? Does anyone know how Akka cluster works? Okay, couple. So an Akka cluster consists of several nodes that run an Akka application. and there are a couple of seed nodes where all the nodes connect to. So of course, that nodes have to be well known. Now we could start that application on Marathon and constrain the deployment to certain nodes that we know are there. And then when the cluster is up, start a cluster singleton. So we only want one instance of that actor to be running on the cluster, because that's actually where the Mesos scheduling and the resource usage collection happens. So what we do then is we connect to Mesos. So we first create a framework info to tell Mesos the name and the user we would like to use to start our tasks. And we tell it give it some other things like failover timeout. So when we are disconnected for such a long time, then we probably have failed and will not come back. So then Mesos will just say, okay, this framework doesn't exist anymore, reclaim all the resources, stop all the tasks that this framework started in the cluster, and go on. We then register with the Mesos framework. So this is an Akka extension where I pass in the actor system to start it, essentially, and then I register the framework. This PID you see there is actually the IP and the port and the name of the master node of Mesos. So you of course don't have to pass in the PID yourself. You can pass in a function that fetches the PID from somewhere, for example, Zookeeper. So as I said, Mesos uses Zookeeper for configuration management, so you can just fetch the current master node from that Zookeeper node. And then you just send it the framework info and ask it to register with Mesos. And when that is successful, you get a stream of messages. So you can connect to that stream and say, for every message I receive, I want to execute a certain operation. And that's how that's how the metrics collection looks like. So I just register with the cluster, the Akka cluster manager, and say I want to receive metrics events. So there's a metrics collector that can tell us for the whole cluster what does the resource usage look like. And we then just collect those resource usages over time and decide when it's time to scale. So when we pass the upper load threshold, we know, so either for the load, so CPU usage, or for the heap, we have to scale up. And then we just say we need to scale up, and whenever we receive a resource offer from Mesos, the scheduler knows, okay, I need to scale up now on that resource, and starts a new task. And of course we send that task the info how to connect to our running cluster so that they can communicate. When we underpass the threshold, we know that it's time to scale down again. So we just tell Mesos, hey, I don't need that task anymore, so please kill it. Okay, so this is what a resource offer message looks like. As I said, we just get a sequence of resource offers that contain information about what slave is that resource for, how many CPUs do I have, how much memory, what ports can I use, and so on. And then we can just look for an offer that matches our needs and tell Mesos, okay, please start my task on that resource. And of course, if I don't need the resources, if there's no matching resource, then I have to decline the offers so that Mesos can schedule them to other frameworks. Then we can also receive status updates, as I said. So whenever we receive a task running update, we want to add that task to the running tasks list so that we can later on check that list and decide to destroy that task if we don't need it anymore. And that's about what you have to do to write a Mesos framework. Of course, you can also react to other events in Mesos, but the essential ones are resource offers and status updates. Or, yeah, well, for whenever a task dies or a machine dies, you will automatically also receive a status update. So there's no real need to know that a machine died or that an executor died. That's just, well, a notification mechanism, I would say. Okay, that's about all I have for today. You can check out our projects on GitHub. You can launch a Mesosphere cluster on Google Compute Engine. So we provide you with an interface to start a Mesos cluster of the size you want. We don't charge you anything extra. You just, of course, have to pay for the cluster yourself. Please join the community if you're interested in Mesos or Marathon. And of course, Mesosphere is hiring, as anybody else. Yeah, thanks for your attention, and I guess we have some time for questions. Yes?
Is there a concept of geography in terms of when you're kicking off processes to have to take multiple data, like if you're distributing multiple data centers?
Sorry, I didn't fully get that.
Say, for example, the Mesos cluster is spans multiple zones, multiple geographies. Say some of your data is in zone A and some is in zone B.
Mm-hmm.
So when processes are kicked off that want to use data in one zone, is there that kind of differentiation?
You mean that you can kind of give a preference where your task should run, or? Yes, you can do that. So you can tag your slaves with attributes and say this slave is running in data center A or data center B, or it has a certain hardware configuration. For example, it has a very powerful GPU, so I can start my GPU tasks there or whatever. Yeah, that's possible. And in a Marathon, you can then use those resource or those attribute tags to add constraints. So there are different constraints, like there's a unique constraint that you can use. So for example, if you put a unique constraint on the host name, then an instance of that app will only run once per host. And you can, of course, match host names or any other attribute name you would like. Other question? Yes.
Can you limit how long it can scale up, to specify for a specific task?
Yes. So when you're in charge of the framework, of course you can say, I don't want to start more than 50 tasks or anything. Like it's really in your hands. Mesos does limit you in some sense. It has a fair scheduling algorithm. So if you have multiple frameworks connected to Mesos, then it will make sure that the resources are being distributed in a fair manner. You can, of course, configure that. So you can say, I have different roles of my frameworks. So you say, for example, my Spark role gets 25% of my cluster because I do so much with Spark that it just needs that power. And you can, of course, also say, this framework is not that important, so it may receive fewer resource offers.
Okay. And another question is, the digital industry actually last year, do you have, like, is it Mesosphere that have to start it, or Mesos can start it itself? Because one of the things that you know a lot is that if I need to scale up, I have to set application, and there is no necessity for a person to go run the machine.
Yes.
Who runs the machine? The machine itself.
Oh, okay. So the machines are already running. Of course, you could think about adding something like an interface for an IPMI or something that then says when all the resources in my cluster are exhausted, I can start up new machines that are on standby, so they're not currently running. But the way we isolate tasks from each other is either you use C groups directly, so Mesos does that for you, it just starts a C group and configures the resources that this C group can use to whatever you set in your task info, or you can start a Docker container. And they also use C groups underneath or Linux containers. So yeah, that's how we do task isolation. Yes?
Follow up to that, but you could, like if you have a Mesos cluster set up with say like 100 nodes, or compute engines, or could you can dynamically add additional ones? Or
Yes. Yes.
And you could, like in theory, if you add an interface flag, you could do that automatically, like focus in a VM and add it to the Mesos cluster.
Of course, yes.
But the autoscaling you showed here takes the task and
Runs it on existing nodes.
an existing, so it fixed task cluster.
Exactly. But yeah, as I said, you can write any additional module you want. So Mesos also has a module API where you can hook into either hook into certain things or just start something on the side that can then communicate with Mesos and do whatever it wants. So you can definitely track the resource usage in your Mesos cluster and can then either start new machines in your data center, or you may even request additional resources from a cloud provider. Yes, there.
On the dependency handling, say I have a Docker container that just waits 1 minute after it's run and then starts listening on the port. If I have things that depend on that, would they see it as initialized after the container itself is running? Or is there some way to say that it's only really initialized once it's listening and ready to accept requests?
Yeah, so in Marathon, you can define, for example, a TCP health check that then tries to connect to that port, and whenever it succeeds, it says this task is healthy now. Heiko?
All right, so you have shown us the dependency for starting the applications in Marathon. Are they only for starting, or are they for the whole life cycle of the application? Which means if like A depends on B, and then somewhere B goes down, Marathon take A down, or
Currently, it doesn't take A down because it may be that B comes back.
Yeah.
So, it will eventually come back because Marathon will take care of that. So, depending on how A has been written, so if it just tries to reconnect to B, then of course the A task will just stay up until B comes back. Of course, if A also crashes because it can't connect to B anymore, then, well, there's kind of a race in that. So it may be that an A task is being started up again before B comes back. But usually you have multiple instances of every app running. And I think it's quite unlikely that all instances go down at the same time. But
In your description, you said something about rolling updates with Marathon?
oh, right. Rolling upgrades, yes. So whenever you want to update your application or your applications, then Marathon does that in a rolling manner. So you can configure the minimum number of running tasks, and you can also configure the maximum over capacity. So when you say, I always need 100% of my tasks running, then Marathon will try, depending on your configuration, to start additional tasks before it brings down the old ones. And if you configure it to, let's say, 50%, then of course it will immediately kill those 50% and then bring up new tasks. And then when those tasks come up, subsequently destroy the old tasks. Of course, only if they are fully available, healthy and everything.
So an old task, a new task would be like a new version of
A new version, exactly, right.
Okay, so I say this task needs 50 instances. Here's a new version, and Marathon will make sure that
Right. There.
When you put up your slides for links and references, they weren't visible on the background. Is there a way to make them visible? And if they're all related to Mesosphere, or is there some other links that we could get to?
Oh, the links were. Oh, sorry. Okay, so the projects are. So Marathon lives under GitHub/Mesosphere/Marathon. Akka and Mesos lives under GitHub.com/DREXIN, which is my name, /Akka Mesos, so Akka minus Mesos. And Mesos itself is an Apache project, so you can either find it on the Apache mirror on GitHub or just on the Apache Git itself. Yes?
With autoscaling, is there any form of a feedback? If you want to scale and increase throughput, but typically adding more instances won't increase throughput. Is there any way for it to check that reach this threshold that it just can't go any faster?
Yes, of course. I mean, as long as you're under control of that framework, you can or add whatever you want. So as I said, this is really writing your own framework. There's currently no framework that does that on its own. I mean, we could think of an additional process that is collecting metrics in your cluster. It doesn't have to be an Akka application. It could be that some monitoring tool of yours is just keeping track of whatever happens in your cluster, and then may from time to time run a script that checks if the resource usage is too high, and then tell Marathon to start new instances. And of course, as I said, you can add or remove whatever you like there. Yes?
Yeah, what's the story around monitoring Marathon?
Yeah, that's an interesting question. Monitoring tasks that you don't know where they're running is pretty hard. There's currently, unfortunately, no way to say whenever this application is running somewhere, I want to start another process alongside that. So either you have to monitor all your servers in your cluster and have to find out what is running where. You can of course ask Marathon, where are these tasks running? But there's unfortunately no way to say this task has to run alongside that task.
I guess what I mean is like Marathon framework itself.
Oh, Marathon framework itself.
How is it running and getting metrics for those?
Okay, yeah, so we have a metrics endpoint that just tells you about execution time of certain methods, so it's not very interesting, but Marathon itself doesn't do that much. So of course we have different endpoints that you can request that give you information about how many tasks it's running and how many applications you have, what the health status of each application is, what errors happened on that application and stuff like that. But Marathon itself, yeah, I mean, you could monitor it as any other application, but yeah, so it's running, how it's running is it runs alongside Mesos. So it's not running itself on Mesos. You could, of course, think about some kind of bootstrapping. So you could write a script that starts a new framework, a fake Marathon framework, and then on that framework starts a couple of Marathon instances that then connect to the original bootstrap framework, and then that bootstrap Marathon deletes itself so that you have a self-contained Marathon cluster that is running on top of Mesos, and whenever one instance fails, it will just restart a new one. But maybe that doesn't really answer your question, or? Okay. Anyone else? Okay, then no more questions. Then thanks for coming and have a nice rest of Scala days.